Alrighty, guys. Well, hopefully I can figure this out. So, let me check real quick, make sure I've got everything working here. We are currently, let's go to live instead. That's perfect. And we'll go back to the editor and split screen and then wait for my transition time. Alrighty, guys. So, sorry it's taken me so long to get this figured out, but I have had a lot of stuff going on in my life recently, and a lot of these changes have really complicated what I'm able to do for the channel. And I really wish I could do more, but you know, that's harder than it sounds. So basically, what's going on right now is that I am getting prepared to move from Columbus, Ohio to Pittsburgh, Pennsylvania. I'll be taking courses at the Pittsburgh Institute of Aeronautics. I'm looking to become was essentially an electrical engineer. So I'll be working on the nav systems and the heads-up displays and all that kind of stuff. All the electronics on an airplane are the things that I will be fixing. And that can be anything from replacing a knob to replacing an IC, diagnosing frequency issues. I mean, anything. I mean, if it pertains to an airplane and it's electronic, that's me. It is a hell of a change. I'll tell you, I haven't, and honestly, I have not been earning a whole hell of a lot here. And I got an offer from family in Gainesville, Florida, for about $100,000 a year, possibly more if I get my AMP certification on top of that. So I'll be transitioning from here to Pittsburgh. That'll be 21 months. And then after Pittsburgh, I'll be going down to Florida and actually buying a house. My girlfriend is not going with me. Basically, what's going to happen is this is going to be her house. She owns, she has, I think, one mortgage. She has already paid the second one off. So this is hers. She's not leaving. She's going to be staying here. She's got a new job that she started about a week and a half ago. And this is where she's going to be staying. So the way this is going to work for Pittsburgh is that I'm going to be in Pittsburgh. She's going to stay here. I go Monday through Friday at Pittsburgh. I do Monday through Friday, 8 a.m. to 2:30. That's the school times. I'll have my own place. I'm going to rent an apartment, and family is paying for everything. So I cannot thank them enough for that, really. Every other weekend or every third weekend or so, I'll be coming back here to Columbus to stay with her for the weekend. We'll go out, go boating. We'll go have dinner. You know, we're not splitting up. It's a little harder to do from a distance. And then, you know, every other weekend or something when she's free and available, she'll come to my place in Pittsburgh and stay with me for the weekend. So we kind of have this thing worked out. It's really not all that bad. When it comes down to Florida, we're going to be seeing a little bit less of each other. And I've stressed that I'm not really... I can't say I like it. Again, we're not splitting up. I'm not single. We don't have any, issues or qualms, or we don't fight, none of that stuff. But she does see this as an opportunity that for me is almost once in a lifetime, and I really cannot pass up. She's okay with it. She'll see me at Key West spring break every year. We'll come home for Christmas, whether that means I come up here to Ohio or she comes down to Florida. Somehow, however that works, we'll find time to see each other. I'm going to set her up with a new computer. We're going to set her up with Skype so that my girlfriend, her daughter, and I can all talk together. Her daughter's currently out in California. We'll be moving back here to Columbus, same vicinity as my girlfriend, somewhere around, I believe it's January or February next year, something like that. So it's not completely ironed out, but that's the general idea. So if I've lost you already, I'm sorry. Like I said, this is a very large transition for me, and I'm a little wigged out about it. I got to be honest. I don't like the idea of leaving her behind. She currently is having some issues with the sciatic nerve, piriformis syndrome, where the muscle is wrapped around the sciatic nerve and it's spasming. So if she's laying down, she's fine. But if she stands up, sits down, tries to walk, go to the bathroom, take a shower, all those things are extremely painful, to the point that I can hear her crying in the morning from the shower. And she's literally like splash, splash, rub, and she gets out. Like, she can't stand to be upright that long. So I'm hoping that before the October quarter, classes start October 1st, before that, hopefully she's over this, because I don't know if I can leave her in that condition and then be like, bye, see ya, I won't see you for like another 3 weeks. That's really bothering me. So yeah. So anyway, that's part of my my massive adventure. Excuse me. Haven't had enough caffeine today, can you tell? So out of curiosity, it says we have 2 people watching. I'm not sure who we've got. I don't know why it's not showing up in the channel views, but that's all right. If you're in here and you'd like to talk, feel free. I can answer some questions. We can talk about whatever. I have about an hour. I have one of my girlfriend's friends needs me to do some painting on the outside of the house. They'll be home about 6 to 6:30, so I need to make sure that I've got all of my stuff packed up and ready to go over there so I can finish that. And I did a few other things for her, so at the end of this, I will get paid, which I could definitely use the money. Because YouTube is not making me a ton of money, I'm just saying. But I do want to go over some things such as this guy. Now I'm going to just kind of back up here a little bit so you can take a shot at this. I'm going to that over here and bring this over without. Whoops, I went to the wrong screen there for a second. Sorry about that. I'm going to check my preview here on my live stream, make sure I didn't screw anything up too bad. I did. But yeah, so all right, yeah. All right, so I'll have an hour and a half window to get this done. Anyway, I do want to go over one of the biggest things that I've been working on, and that is this guy right here. I'm going to bring him a little bit more front and center so you can see what's going on with this. This is a massive work in progress. I know I've hinted and poked at this a few times, but I really wanted to show you guys what's been happening with this, because it is I am so proud of this thing, I don't even know where to start. Okay, all right, so I'm going to go ahead and move this camera a little bit closer so don't get all weird and sick on me here, but I don't have one of those like ultra fancy rigs and stuff that I can just, you know, articulate all over the place, you know what I'm saying? That is not me. So we will tighten this down like that. All right. So, with the exception of ignoring this stuff here, camera up just a tad here. Okay. So with the exception of this USB cable here, this Raspberry Pi camera cable right here, I've got a couple things going. And I know I am not the greatest at this live stream thing. Sorry, I'm just not. But basically what we've got is this system that I had started a while back. I started with the ANET AM8, and some of you might have seen me do this before. I've done a lot of changes. Mostly it's taking off all the electronics here, the power supply, all that fun stuff, take it out of sight and put it underneath. Now this was a radical idea at the time, and I still think that it was just way stupid overkill, but come on. This thing looks sweet, does it not? Okay? So basically, here's what's happening. I need to check out and make sure that my stuff is being done right here, because it looks like something's not happening. Okay. Yeah, there we go. Just making sure it was public. I did that mistake earlier. All right. So I'm going to go over as many parts of this as I can in a reasonable time and give you guys an idea what's going on here. So basically, this is an ANET A8 is how it started. It's been converted to an ANET AM8. It was all metal. So this black aluminum extrusion set is from Rat Rig. I purchased, God, I don't even know. So many of these parts have been sourced from so many places, I really can't keep track. I probably should have, but I really didn't, and I've been through so many revisions, I don't even know where to go. So, the atomic PLA is all of the green that is here. It may not show up very green in the video, but it is basically a neon green, so if it doesn't look like that, I'm sorry. My preview seems to show it as kind of like a brightish, almost white, which it's not. But think neon green, okay? So everything that's green on this was printed in atomic PLA at 50% infill, 0.2 millimeter layer height, and in some cases 100% solid, such as these guide rail mounts here and these pieces up top. I had to adjust a lot of these because I wanted rounded corners. I don't want something that's sharp. I didn't want to be able to, catch and cut myself while I'm moving this around or, whatever. So that was another consideration. Now, to the meat of this, here's a really cool thing, and you should be able to see this really well on video. So here is the printable area. It's the same stock build plate, although I put on something special on top. I'll show you that in a second. But basically, watch behind this. Yeah, like that? Check this out. See this drag chain right here? Now watch this. I'll do it again. And just kind of watch where the drag chain is and see if you can figure out what's going on here. And by the way, that is completely silent. Now there's a little bit because I'm moving it by hand, but nothing's rubbing, and this is awesome. Let me get the mic a little closer. Okay, let me do this again, see if you can hear it. Okay, now it's not plugged in. Hey, Rodrigo, buddy, how's it going? I was wondering when someone else I recognize might pop in here. I'm just going over my the entirety of my AM8, which should be done within the next 2 weeks. I know I keep saying 2 weeks, but I have the last couple of things on order, and I'll tell you what those are here. So if you want to stick around, I have until roughly 6 o'clock. So hope to see you here. If you got any questions, obviously go ahead and let me know. Bring this closer so I can read comments. So let me do this. Now watch the drag chain in the back here. Right? You don't see any wires. Okay? There's no loose wires hanging around. Nothing comes out the back of the printer. It doesn't look all stupid, does it? Now, I haven't attached this plate yet. I haven't soldered it on. And part of that is because I took off the connector. I literally just cut it off. And you'll understand why when I take off the plate. Yep, it's that simple, right? So I completely desoldered it from here. And by the way, that was an absolute pain. I'm not even kidding. And so I came up with this little bed riser piece here. Uses the same stock screws that hold the plate on, but it's no longer springy. You lose that extra bounce in the table. I wanted this thing to be completely solid and not transfer any, as little motion as possible, basically. So here are my wires right here. So we have the hot, ground, or the negative, and then the two sensor wires are here. And they will be soldered on. There's a little notch right here. I don't know if you can tell or not. You might be able to turn this. Okay. Let me bring this view back up real quick. Okay. There's a little notch cut out right here, and that is where this build plate will sit in here, and that's to make room for the soldered connections where these guys are going to go on. The wires come through here, wrap around the back, come down through this block. Inside the block, this actually has a hollow tube inside of it, down behind the Y-axis motor, and then underneath, and then that's where things kind of start looking a little bit ugly until I kind of clean them up. I got to tie them off in certain places and all that, but the wires disappear. So what you're probably curious about is, what does this look like when I move it forward and backward? So here's the chain. Move my mic back. Go ahead and watch the drag chain. Watch what happens. See that? Doesn't come all the way, doesn't hit. And if I come back out, it's fine. Now I could probably have gone a little bit more. I had a little bit of extra chain left that I could have taken out. I could have shortened this by one link. By the way, these are 7mm by 7mm inner diameter drag chain. And is attached with laptop screws. And for the life of me, off the top of my head, I don't remember what the thread type is. I honestly don't remember. But again, everything's printed in PLA. It doesn't have to be ABS. It's not going to get that hot. This printer's never going to do ABS anyway. But yeah, they're just bare wires. They're routed in here. I don't have them in any form of sleeving like this, which I have used in a couple places, and you probably see that up top here in a second. But yeah, this drag chain is held in actually pretty tight. It's not going anywhere. And as you can see, I still have lots of room here, and vertically it sits below the build plate and above this cross brace, so it doesn't hit anything. It doesn't hit on itself because it's being done vertically instead. This sits horizontally, and it makes literally no sound no matter how fast you move this. That was a big key piece for me. I probably spent a week and a half just designing this lift, and then another week or so designing the drag chain mount and the rear block back here. So yeah, that's really cool, and it'll do a tighter. It'll do a tighter radius, but tighter also made a little bit more noise. So I bumped it out from 38. No, what was it? 50 millimeters or something to 65. And now it's completely quiet. So, you know, perfect. It just means this is going to be harder to replace, but I mean, that's just kind of the price you pay. So once these are soldered on, there's not going to be another connector in here. I don't want something that can bang against the metal or the plastic and make noise while I'm printing. So rather than having a disconnectable build plate, it's just going to be soldered on. If I need to replace it, I will desolder it and solder onto the new one if I ever have to. So whatever, it's fine. Now the great thing about this build plate now is that you'll notice there's no TH3D build surface on here. And I'm sorry, Tim, but I wanted to give something a try in addition to, let's see, we'll go this way, having this thing have the cleanest black look ever, which is awesome. And that is that this is a magnetic surface. Now, I don't know how well this is going to work. I have yet to try this on any of my printers. This was an Amazon find, I believe. I want to say 30 bucks, maybe? I really don't remember. But it's basically, it feels like the exact same surface style as TH3D's build mat or build tack, something like that. And there is a difference between orienting this top magnetic piece on its lower counterpart down here this way as opposed to 90 degrees. This way it's very weak, but if you turn it 90, it becomes extremely strong. It's a little bit strange. Did I build that? What piece are you referring to there, Rodrigo? Talking about the whole thing, or just this piece, or the cute bed skirt, which I think is absolutely fantastic? I'm gonna give him a second to respond to that, and I'll go ahead and move on. And in a second, we will actually go underneath, and you get to see what's down there. So while I'm waiting for him to answer, just give me half a second. I need to respond to my girlfriend. She just called. Okay. Sorry, I still have to take care of everyday real life things. So I'll respond to Rodrigo here in a second. I'm not seeing him replying quite yet. But yeah, so I do have one full, completely new TH3D build mat, but I didn't really want to go that route because I wanted to keep the theme all together the same as much as possible. The whole thing, or did you modificate? This was originally an ANET A8, became an AM8, which is the metal framing that you're seeing here. And then even beyond that, I've stripped out all the electronics and everything. Everything's underneath. I've added in MOSFETs, fans, Raspberry Pi, upgraded wires, easy ABL. I mean, this thing got the works, believe me. So I'm hoping this thing is as good as I would like it to be when I'm done. All right, let me set that aside real quick. Okay, so we'll get to that part in a second. Let me take you up top here. Okay, I don't know if I can get that much closer and make it easy to see. All right, what did she say? I'm sorry, this is all part of live stream, you know what I'm saying? All right, I'll keep this here in case she calls me. Bad English? No, man, it's totally cool. I have no problem with it. I know what you're saying. It's cool. So up here, a lot of magic has happened. I've combined between just this mount took me 3 weeks because there's a lot of custom work in here. custom screws. A couple things didn't go right, but I really didn't feel like redoing them, so they kind of look stupid. But I tried, you know what I'm saying? I wish that sticker would come off of there. I don't like how that looks. Hey, that cleans it up. Check that out. All right. So we have an Easy ABL 18mm V2 probe. We have a 5015 fan. I got this from TH3D as well. Also from TH3D is the V6 hot end that they sell. It's the package. This is obviously the 12 volt version because this is an ANET. I have a sock on here, an upgraded thermistor, an upgraded hot end, not an upgraded cartridge, just an upgraded thermistor on it. I 3D printed all of these little back plates that sandwich together. There's no screws in the back here anymore that hold this belt in here. It's simply a printed tooth thing that you slide them in to whatever length you need, and they stay that way. So it actually did pretty good. I 3D printed both ends here to replace the plastic. I have oh god, this is embarrassing. You know what I'm saying, these stupid little things. I can't think what the hell. Anti-backlash nuts. Oh my god, that took me way too long to figure that out. So yeah, I've got, everything here is pretty solid actually. I don't have any upgraded rollers or anything on here. The only thing I did upgrade are the belts to a fiberglass reinforced belt instead of a steel reinforced belt. This allows it to go around the curves on your pulleys smoother, and especially when they're going over something on this side where it's a smooth roller, it won't cause quite as much vibration in here, and hopefully that won't transfer back into the part. At least that's the idea. Here you can see this is what I was saying is my nylon braided sleeving. I did this, which contains all of my wiring for the probe, the fan, the sensor, the hot cartridge, the thermistor, and the TH3D tough tube, which is going through here, comes all the way up, and then right about here they split out. Now I may be able to turn this around enough where you can see this. I have so many things, I'm trying not to tear anything apart here. So this is where it splits off. It brings a little bit closer. Okay. So it splits off here, and I literally just opened up a side. I didn't cut it. I just opened up a side in the nylon braid, put some heat shrink on this side of it just to keep it tight so it can't slide back, and brought the tough tube out and into a tough extruder. This one I purchased from TH3D, and it looks like it might need a little work. That's right. But here, I had a generic one that I bought. Sorry, Tim. And it ended up being a complete flop. I think I know what was wrong with it now, but now that I have this one installed from him, it's smooth, it works, it's great. The only thing I have to do is I'm going to create a, in fact, you know what, let me get a spare roll here. Hang on a second. I said spare roll. All right. So what I'm going to do, and this is at least my current plan, is that I'm going to create a drop-on filament holder that takes the filament back up here, this direction. And I'm going to have a printed part that's probably going to mount either onto the back here or onto the top, feed around, and will cause the filament to come out like this, turn the corner, real shallow corner, and into the extruder like that, and then it can fill in. But everything can all be done. It can be set right here. Now, if this is here, mind you, it'll never get in the way, even if the x-axis is all the way to home side. So I can actually have this sitting back a little bit, so that the back of this is in line with the back of the printer. And with this, changes are easy. It has a low profile. I will have to work on how I'm going to handle retractions. So if I push it back, obviously this isn't going to retract back this way. I have to figure out, will it not push it back so far that it drops off the edge and then starts to unspool. So I have some things to take into consideration, but in the meantime, I can actually set this up, you know, somewhere behind the printer for now, just on a little stand or something, and be able to at least print with it until I can figure that part out. Ronnie, oh hey buddy, how's it going? You said upgrade thermistor. I need to buy one for a raw build plate I bought. What model? Kapton tape to keep it stuck? No, thermistors on the hot end do not take Kapton tape. They are, at least all the ones that I've ever dealt with, they are in the heat block and they are screwed in. They have a tiny little screw. You know what, I can't get this around far enough to show you. But it goes right into the side of the hot end with a tiny little screw, just sets in the block. You tighten down the screw just ever so slightly, and then you run your wires up and you're done. I don't use Kapton tape on anything. They do have little silicon socks. I'm sorry, they're not silicon. I think they might be like fiberglass socks. They're yellow and they look like they have that yellow tape over them that they wrap around the heater block, and that's where they're using Kapton tape. I wouldn't do that personally. I would just use the silicon socks. They stay on very well, and they're much easier to clean off. And it gives you a very slim surface to work with, so all of the nozzle also stays hot. So you said for build plate, thermistor for the build plate. No. Hold on, here it is. Let me bring this back up for you. So, on the back of the build plate here, your thermistor, you have LEDs here, resistor for LEDs, your power connections, and your thermistor is actually, I don't know if you're going to be able to see this or not. Right there in the center, it's hardwired in. That's your thermistor for the build plate, at least for this style. To my knowledge, I'm not aware of another style build plate that uses a different location for the thermistor. So you really, as far as I can tell, it doesn't look like you're actually able to even change the thermistor on here if it goes bad. It looks like it's actually epoxied in place. The solder connections are easy to get to, but I think the thermistor head itself is pretty much stuck there. So if the thermistor goes bad on your build plate, you just have to get a new build plate. The thermistor on your hot end goes bad, you simply unscrew it, pull the wire out, put in a new one, tighten it down, feed your wires, hook them up, you're done. I know that sounded easier when I said it, but yeah, you know. Okay, so yes, let me turn this around again, and then we'll get to the exciting part, which is underneath. Make sure I am not still plugged in here. Okay. All right, so here's another cool one. And that is right over here. Now this is a mount that goes in between the original plastic, or in this case my PLA printed, and the X-axis motor. And what this does is, this is what I'm saying, I'm waiting on a part to arrive so I can finish this install. Let me take the X-stop switch piece here. Come on, get out of my way. This is one unruly wire, I tell you. All right. So what this does is there's another piece right here. And this cool looking guy is I need to finalize filing him down, but I'll just put it in that much until I can get it filed down the final amount. But basically, this is my power switch. Now let me bump this down here so you can see what's going on with this. What this is going to do is this sits in like that. Now you probably can't see this. Obviously, the switch will go right in here, and everything will be pushed together. But right now I have it apart because I need to wire it. And this is where my power connection is. It's in the back, behind everything, so you don't see it. It's out of the way, and it has a switch on it that will turn everything off at the source. Now, here's the thing. This is a red switch. This is what came with this this piece, this IEC, oh hell, IEC 320, I want to say. But it's a standard AC socket with a switch, 15 amp. And this one is fused, specifically. But this is a red switch. I ordered a green one because OCD me wanted even my power switch. I wanted to match the colors on the printer. Talk about OCD, right? Here, I'll give you another example of OCD in my box of printer goodness here. What's that down there at the bottom? Yep, that is a green power cable because because I can. So I'm literally going all out with this. This is absolutely fantastic. I love this. I am more than excited to get this done. I hope you guys are too. I missed Ronnie's last comment here. Mine is close to yours, but it has a hole in the center to add a thermistor. Ziltech may be able to advise since they sold it. You said you had an upgraded one. I just thought you might know. Gotcha. I'll have to look into that because I'm not sure how that one's built. But as far as just acquiring some more knowledge, it's probably not a bad idea that I go figure it out. But let me go ahead and attach this bottom piece very generically here. And this will give you an idea what we're going to be going up against here. So what I have are some shorter bolts that have been used throughout the entire printer and some hammerhead nuts, specifically so that I don't have to slide them into the frame. So here's what we're going to do. We're going to put on this top one here. I'm going to start the hammerhead nut. Start that in. Come on, give me my tool back. Thank you. And there we have it. See? Nice and solid. Now this has 4 mounts. There's 2 on one side and then 2 on this part of the frame, so it's held into the corner. Now this is an example of what I'm talking about with this. I'm actually going to bring that up just a tad. You're going to love this. So what I've got is the leftover part to my drag chain from this piece. This will mount here like that, and this little hole in the top is where the wires come down in. So this mounts right here. Now obviously this won't be quite as long, but let's say that's there, and this is right here. And as the x-axis, z-axis, I'm sorry, moves up and down, this, all right, will come right along like this, up the back, basically out of sight, and this this radius has the same difference as the one that's here. Now it didn't have to be, because like I said, the X and the Y move fast, the Z does not. So if you have, here I'll even do it in front of the mic. Hear that? Now if I were to open this up and go sideways, this is what it would sound like. See? Almost nothing. That's why I do it sideways. Vertically, doesn't matter. It never moves fast enough for that to make a difference. But the chain comes and takes the 4 wires for the motor and the 2 for the X end stop. We'll route them together. There's a little clip inside of here that you can't see, but it's going to hold these wires tight up against the back. They then come together down through this hole on this side, through the hole on this side over here, and from there they go into the drag chain, down the side, into this box. This box has a gap in the bottom, in this bottom corner down here. All the wires, all three from the power input and the 6 coming from up here, all go down through that hole, end up underneath, out of sight, and everything gets put away. That's how easy that is. Drag chains, I know some people swear these things are stupid, they make noise, they're not worth it, blah, blah, blah. If you can use them correctly, they are very much worth it. Now, I wanted to originally change these wires so that they were hidden. And that was going to mean put them in nylon braid and feed that through this. Now, the braid I have is 1/2 inch, so it's too big. I could have gone with 1/4 inch, but I think it would have been too tight. And as it is, this is actually probably plenty. And to be honest, if a little bit of wire shows, I guess it's okay. I'll change it later. Just for example, I got the 200 by 300 here. I missed the little fact that there is no wiring or temp sensor at all. Oh, well, yeah. That would be the same thing that goes for my Monoprice i3 Mini. No heated build plate, which means no thermistor, which means no wiring, which means no drag chain, you know, okay. Okay. So my girlfriend just got home. I'm going to okay, just so she doesn't waltz in here, you know what I'm saying? All right, so you've pretty much seen what's up top. Oh, and let me go ahead and set this here. There's this piece. So right here is a printed plate. It's the just shy of the width of this 40 mil frame. 3 bolts, and this holds all of the wires, both for the extruder motor here, which is in some braid. It's actually too big. The braid could have been smaller. And all of the wires, with the exception of the tough tube, from the extruder up on this side, they meet up here, and they come down here and end up, which unfortunately shows a little bit, but that's all right, and then pops down, again, out of sight because it's behind this mount here, ends up underneath. So I've taken a lot of work here to make sure everything is as clean and hidden as absolutely possible. Now comes the fun part. We're going to turn this guy upside down, and you guys are going to see what's on the other side. But first, I need to take off this guy, because right now he's going to get in my way. Come on, give me that back. Let me put my tool back here. Okay. All right, let's go ahead and turn this guy over. Let's do it this way. Okay. All right, so what I need to do is I need to lower the camera a lot, and we'll get you guys up close and personal here. That should probably do it. All right, what do you got there? Yeah, we'll show that. Sure. Okay, yeah, I'll have to check that out here in a bit. But here is my here is the underside of my monstrosity. So basically, we have a Meanwhile power supply. This is the LRS 35012. It's a 29 amp power supply. It is slim. I forget what the height is. I think it's 30 millimeters. But this should be able to handle absolutely everything. And I've done a butt ton of work under here. If this looks confusing to you, then that probably means I did my job. Like, not even kidding, okay? So there's a lot of fans down here, and one of them is probably more hidden than you think. So we'll start off with the obvious here. We have the fan in the power supply. My camera's still bouncing. Fan in the power supply. We have a Sunon maglev fan here for the main board. This is a 60 millimeter fan here. And we have a 40 millimeter fan down here for the Raspberry Pi. I'm currently using Raspberry Pi 3B Plus, fully upgraded. I am running TH3D's Easy Pi system on this with a couple tweaks and changes of my own. This is not currently based on Octoprint 016 016.0. I'm sorry, 016.0. This is still on 015.1. I think 15.1 was the last one, not 15.0. But either way, so it's still based on the old version. I'm talking with Tim about getting this thing updated to be current at the very least. But yeah, so we do have a camera cable for a Pi camera, and that is what I'm going to be using to monitor my prints. It is this guy. So this little tiny camera is what's going to be in a custom housing, and it'll probably mount somewhere to the right of the print bed, so I can just run the cable like this. I'll print a little piece on the side to hide the cabling, and it'll stick up or maybe fold down every so often, I don't know. But it'll be able to see the prints as they're going and be able to do a time lapse and everything else. So, all right. It has its own power supply through a 5 volt, not turned up to 5.1, but a 5 volt 3 amp buck converter running directly off of the power supply here. The output is rigged up to a micro USB cable, which is not this one right here. It's actually this guy right here, and I'll explain why in just a second. So I do want to show you something. We have two MOSFETs here. One is for the extruder, one is for the hotbed, and I believe the hotbed is this one and the extruder is this one. After all this work, I don't remember. I've changed it up so many times. So as you see, I don't have all of my wires in. I'm still missing a couple connectors, like this guy right here. This is actually the Y-axis motor. He goes over here. I just don't have him in because I've been moving it back and forth. I didn't want to feed power back into the line. I am obviously going to redo my power connections here, which are currently just sitting over on the side. And I have to wire in the base of my EasyABL probe, which will fit back up on this back side. Excess for this cabling is, I'll just give you a generic sample idea since I can't really make this any shorter. In fact, I don't think they make any shorter cables, but let me do this. And before it goes out, excess cables you can put up in here and then zip ties very lightly to hold them in place. So you get over there. I just printed this guy as the mount for the Raspberry Pi to hold this 40 millimeter fan. I just did this last night. Took about half an hour. It was a real quick slap together design, but apparently it works. So, I mean, I guess if you guys want this, I'll try to make this available, including the mount here that I used to mount the 60 millimeter fan for the main board. Leaves everything available. You can still read what each connector is. I left an extra slot here. And this side, you can actually read, if you get the right angle, you can read it here, or you can read it through the fan to know what the connections are. You still have access to the display cable, which will come out up here, again, bundle up, come over, and then plug in, and then be zip tied in place. All my power cables and everything are routed through. They are sorted so that I have a load on each terminal that is more or less spread evenly. This looks super difficult. Let me give you a hint. It was. I mean, well, it wasn't really for me. I'm so OCD. I probably could have had this done in a month, but I just don't operate like that. So, you know, and then shipping times for getting everything here was, you know, a pain. Wires. So this is motor wire from the, oh, what the hell is this? This one comes down through here. That means this is the extruder motor. And as you can tell, this is not where a splice was. If you're seeing the clear heat shrink tubing, it was just kind of to keep things, you know, bundled together. I didn't want to use zip ties. This is where I made some connections here to extend the wires out to here using the original ends. So I spliced about 12 inches of extra cable in. Now this all looks bad, but when everything's done, mind you, everything is going to tuck down and be zip tied to these little donut shaped attachment rings. So everything gets pulled up underneath, out of the way. And I've done a few tests already where I just had wires splayed about, and there's no interference to my knowledge. So running the stepper wires next to the main power wire, whatever, it doesn't seem to affect anything. So, I mean, that's always cool. But then again, I need to, this is really the only high input, so it really shouldn't do anything else. But your wires are all separated by sides, so nothing's getting in the way of fans. There is a 20 millimeter gap between the base of the frame and where these rubber feet sit on the surface that you're putting them on. So you have that much room for air to get underneath so that these fans can work appropriately. MOSFETs are obviously hooked up. There's a little tiny fan here. Now you remember the fans that are on the E3D V6 hot end, those tiny little 30 millimeter fans? There's one of those right here. It's also a 12 volt, and what this is doing is this is taking the air that is just kind of in here and is blowing it across this this first MOSFET. There's a little channel behind here that'll blow through that and end up blowing across this one as well as along the face of it. So it cools the MOSFETs. It's very quiet, which is awesome. So I have a fan here. I have a 30 mil, a 40 mil, a 60 mil, another 60 mil built into the power supply. Whole bunch of, you know, I could go over the wiring for days, but one thing I do want to show you is we're going to take this little guy right here. This is a current voltage USB test meter thingy. You guys have probably seen this stuff on eBay or Amazon or whatever. But USB meter, I forget, what was the brand? Crap. I don't remember the brand, but it's a meter. It's a really good one. I have a couple of these. By the way, if you guys want to test things, this one has all sorts of different input-output. It's a different display style. And I have one more that I'm going to be using in a future project, so hopefully you guys stick around for that. But let's hook this guy up, and I want to show you how much this Pi takes. For those that are curious, what this Raspberry Pi takes as a power consumption at idle running Easy Pi, or basically a tweaked out Octoprint, without doing any actual work. So we're going to take this guy as the input, plug him in there, and the other end of my unfortunately stupidly long USB cable is going to be the output. Okay, move this. There we go. The last time I did this, I wasn't looking, and the tip of this thing got caught in the fan, so I don't want to break this thing off. Let's go ahead and move that back. All right, so I'm gonna go ahead and plug this in. It is going to be a little bit loud. I'm gonna move my mic a little bit closer to me here. Let's go ahead and plug this in. Ru Deng. I'm sorry, that was what it was. Okay. I'm really quickly going to disconnect this camera so I can bring this a little bit closer and show you what's going on. All right. So here is the Raspberry Pi, and for some reason, come on, you got to focus at some point. Wow, isn't that bad? Well, it almost had it. But yeah, so we're at 4.95 volts, basically a 5 volt, 380 milliamp. And that is just running it idle. Obviously, I'm not doing a print or anything, but that's what that's putting out. So if you guys are curious how much your Raspberry Pi is going to take as far as power consumption, it's really not that much. In fact, a 2.5 amp power supply, if you're running a Raspberry Pi on your 3D printer, is not going to take anywhere near 2.5 amp. Okay, a 1.5 would probably be more than sufficient. The reason they say 2.5 is to make up for the USB ports in case you have a USB webcam or a hard drive or some other peripherals or something that take power from USB. You need to be able to feed more power to the Pi to make up for that. Otherwise, you'll get a low voltage and the Pi will complain and or shut off. And apparently this thing does not like to focus on a shiny display. It's having all sorts of problems. Look at that. So yeah, I think we can even do here. All right, so it's very hard to turn. Oh man, I really wish you could see that. That sucks. Yeah, at some point I'm gonna get a better camera than this, so you guys are able to see the display. Sort of, but it doesn't like to stay that way. But anyway, this is also saying same thing. And we can get a little chart here, which will display power usage over time, including voltage. So I got voltage in, I believe voltage is yellow and current is blue. And if it's not focusing, but bottom left, bottom right there are the numbers to show you. So yeah, that's what a Raspberry Pi takes. If you guys are wondering about hooking this into your system, in all honesty, you could probably use a whole lot smaller power supply, but you know, it just kind of depends on what you want to have hooked up. I will be doing, once everything is on, including the camera, the cables, and I start a print, I'm going to hook this up through a power monitoring plug. And if you guys want one I recommend, let me show you two different ones that I have here. I'm going to put this guy back, not on settings. I'm going to set it back here. So, okay, now here's one style right here. Okay, here's one. I don't really like this one a whole lot. Obviously, there's no remote access. You can't use your phone to look at it from afar. You have to get down at a weird angle to see it. Good thing this thing was cheap, but it's basically like a kilowatt meter. But I would not recommend this kind. It's very difficult to see. I don't like it. And trying to set it to get the correct reading, it doesn't really tell you what it is, so you have to kind of figure out the reading measurements and scale by trial and error. It's really bad. So trying to set it at, say, 5.8 cents per kilowatt hour, and then you're trying to figure out how much it's using, it's almost impossible. I gave up on it after about 3 hours. So, I mean, it obviously does work, but reading it is near impossible. So, the better one is these guys. These are TP-Link. This is the 110, I believe. Yes, this is the 110. So the 110 has energy monitoring that you can use through an app on your phone. Now this, I think you guys are really going to like this, so I definitely want to show you. Let me go ahead and turn this, power that off. I'm going to hook up the camera real quick, and I'm going to show you an example of how this works. I think you guys are going to like this. And then after that, I think it's about time for me to go. So I will leave you looking at this for a minute. I am very quickly going to hook this back up the correct way. Which is going to take a second, so just bear with me. I'm doing a little bit of surgery on my thing here. That's the problem. Working on a glass table, everything slides around. Okay. Okay, there's that. There we go. And we're back in. All right. So I'm going to go ahead and hook this guy up to my wall. Alright. And he is connected through Wi-Fi. He is in the middle of connecting right now. Let me go ahead here and bump into my Casa app. Alright, so that's set for there. It is still connecting, so it's going to take a second here. But I have a couple other things that are connected here. So one, I don't know if this is going to work. So hang tight with me. I need to find my controls here so you guys can actually see what's going on. Because that's pretty bad if you can't even webcam controller. All right, and there we go. We'll bring that down a little bit so you can actually see what's going on. It's amazing. All right, so I don't really care about white balance, but whatever. And then, oh, stop with the autofocus. Okay. All right. So what we have here are, sorry if you can't see this, because unfortunately this is about as good as this is going to get. There we go. So I have three things on. Currently, I swapped over the light in my room above here to the AM8 switch. See how the light went out? Yep. So this is not hooked up over local network. Notice I'm not on Wi-Fi. Now what we can do here is CR10S. EM is for energy monitoring. What I'm going to do is I'm going to turn that on, which is actually hooked up to this right now. Let me move my camera controls out of the way so I can see my own preview window. And we're going to go ahead and there we are. We're powered on. Okay, so Pi is on, main board's on, power supply's on, blah, blah, blah. I am going to turn soldering off because I have my soldering station here. I forgot about that. And now we're going to go into this guy. So we can do a full main on and off from this, or we can go into look at energy. And now you get to see its current power consumption. Now you can also do this for actual runtime, which goes for hours, or you can view this as current power usage or total power usage on the right side. So we're looking at 10 watts at idle. You can ignore the daily average. I haven't used this thing consistently. I've just been kind of poking around with it. But that's not terrible. You can set a timer. You can set it'll only run for so long. You can set it to turn off when you're away. You can set it up for a schedule. So maybe you want it to turn on when you get home, and then go ahead and start a print after that if you'd like. And again, you can see right back here, and it's off. It's that quick. So I can do this from anywhere. Now, if I also had a Casa cam, that I could also monitor everything that's going on in the house. And I'll probably eventually get one, but let me. Whoops! I lost my viewing window. There it is. So the other thing is that through Octoprint, what I can do, and I'm going to try to do this on here. So let me go back and turn this guy on. The Raspberry Pi is going to have to reconnect. I'm going to get out of this real quick, and I'm going to get into my Pi because I happen to know the IP address. All right. I think the Pi is still booting here, so we'll give it just a second, and we will be back into this here. And it is not completely up yet. Okay, so just give me a second. As soon as this comes up, we will hop on in. It may take a little while. Oh, I see what I did. Hang on a minute. This one is on me. I'm in the middle of changing up a lot of stuff, so you know, I'm still trying to remember what all of my settings are. So you'll have to just give me a second here. All right, let me come over to here, and because I know it worked on here. 6.8. I think it's powered on. Yep, it's powered on. So it should be working. And of course, you know, go figure, when I go to show this to you guys, it isn't. All right, well, anyway, you guys have probably seen Octoprint. It's really, I mean, nothing terribly new. I'm going to use Advanced IP Scanner real quick. Let me just go ahead and see if I can find what we're doing here. And then I can show that to you guys again. It's going to take a second to scan. I think the IP address might have changed on me. Nope, that's all three of my TP-Link smart sockets. And it's not 255. I know, this is absolutely awesome. Right in the middle of trying to show you guys, and this happens. So we're almost done scanning. I may need to go and configure something else because I redid the install, and I changed a couple things, so I might be looking in the wrong place. And I very well might be. let me search on... Well, no, that should have come up already then. Kind of surprised it's not working. Let me go ahead and disconnect it, reconnect it, and this will pretty much be the end of this this stream. Okay. Eventually, I may add in a switch that'll turn on and off the Pi. Just make like a remote thing underneath here. That'll just make that easier. Alright, I need to poke at something real quick, guys. That did not sound right. But I need to make sure that my Pi is actually working. It is, but it is extremely slow. And it is not showing up for some odd reason. Back to my chat here. Make sure I'm not leaving you guys in the dark. We got 2 watching, so yeah. Sorry, guys. I mean, I know this should have been more exciting, but I'll try this one more time. If it doesn't show up, I will reconfigure this and figure out what's going on another time. I'm not going to make you guys suffer through it any more than necessary. But it should be working. I don't know what's going on. Obviously, I don't have the display hooked up to it, and it's not showing up. So, you know, whatever. It is what it is. Alright, so that's autofocus advanced settings. Let's put everything back to where we were. Autofocus, auto, gain, blah, blah, blah. And for some reason it's still... Hey, there it goes. Now it's catching up. Alright. Kill that off. That sucks. I don't know why it's not coming up. But, so, yeah. That is my... Let me go ahead and turn this guy off through my Casa app here. And... Ta-da! It's done. And there go the fans stopping real quick. All right. So, this is pretty much everything I've got so far. Like I said, I need to wire up a couple things. I'm waiting on my drag chain and my green power switch. I do need to go out and buy a couple of the little spade connectors that I need to wire up all the connectors back here. And then I can start tossing everything together, and I will upload a new firmware to the main board here, and everything should be good. One thing also to note, I wanted to show you, forgot about this. And that is a very short USB cable here. Back to my live view. Real short USB cable is going to be like this. One end goes into the Pi, like that. The other end, now that we're wrapped around the wrong cable, goes like this and ends up in the main board, and that's how the connection happens. The short little cable. Now, if I could make one shorter, I probably would. But this one happens to be braided. It's shielded and everything, so I'm just going to go ahead and use this one. But yeah, so this is currently where all of my stuff stands. I just wanted to give you guys a heads up. Like I said, I'm going to be super busy with a lot of things here between now and probably December, through the first quarter of Pittsburgh. So this will get done, and I will make an absolutely awesome, correct video, not a live stream, but an actual video of all of this when that time comes. But yeah, for now, hope you guys like it. I need to head out. I've got some things I have to do before it starts raining tonight. I hopefully will give you guys some more updates and maybe get some other types of videos out here fairly soon. I do need to get that done. I'm sorry, but you know, life takes precedence over my YouTube channel. If I made enough money doing this to do a full-time job, you guys obviously would get more content, but I've got things that I have to get done. So sorry about the delay, guys. Hope you guys enjoy everything. If you have any questions, go ahead and let me know. You can always leave a comment in the comment section. I will try to respond to everything that I can. If you have any suggestions for maybe an added part or a different way to attach something, I am all ears. I will try to update all of my little printed STL pieces as much as possible, and hopefully get some of the stuff out to you guys if you think they're going to be useful. So if you see a part that you think you want or that you can use and you'd like the model for it, go ahead and let me know. And with that, guys, I am going to sign out. I hope to see you guys again. Thank you for watching. Like, share, and subscribe, guys, and I will definitely see you, hopefully soon, in another video. Thanks for watching.